Dear students, today we are going to look into the graph of a quadratic function and the different terminologies associated with that graph. We will also see that how to sketch the graph of a quadratic function from its equation. So let us start. You can see here the first point, the general shape of the graph of a quadratic function. Whenever you draw the graph of any quadratic function, it ends up into a shape like that or like this, right? A U shape, basically, you can say that. This shape is called a parabola. So the graph of a quadratic function is always a parabola, right? Now this graph has certain properties. If in the general form of the equation, which is ax squared plus bx plus c, this is the general form of the quadratic function. If the coefficient of x squared, which is a in that case, is positive, it means that if the value of a is greater than 0 or a is positive, then you will get a graph of this type in which the point here, which is known as vertex, this point will be at the lowest part of this parabola. And in this case, we can say that the curve has a minimum point, right? And this minimum point occurs at the lowest point of the curve. So there is a concept of minimum and maximum related to the general shape of the curve. So if a is greater than 0, then the vertex will be the minimum point on the let me write it down here. Vertex is vertex is the minimum point. And if the coefficient of x squared is negative, it means if a is less than 0, then you will end up an inverted parabola, right? In that case, the vertex is the maximum point of this parabola, right? So there is a concept of minimum and maximum. If the coefficient of x squared is positive, then vertex will be at minimum, and if the coefficient of x squared is negative, then the vertex of the quadratic curve is at its maximum. Okay? Vertex is, of course, in the set of Cartesian coordinates, so it will have an x value and a y value. So the coordinate of vertex, we will see how we can work them out algebraically in the coming session. Then this graph has a line of symmetry, and this line of symmetry always passes through its vertex in any case, right? So graph of the quadratic function is symmetrical along this line of symmetry. So we can say that, for example, this part of the graph is an image of this part, and this is basically the mirror line. Same, this part of the graph is an image of this part, and this is our mirror line. So this line has a certain equation which we can work out in the coming sessions. So anyhow, what you need to understand here, that the general shape of a quadratic function is known as a parabola, and this parabola has a minimum point at its vertex if a is greater than 0, and this vertex is the maximum point of the parabola if the coefficient of x square is less than 0. Then there is a line of symmetry which always passes through the vertex, and the graph is symmetrical along this line of symmetry. Okay, then there is another concept here, the axis intercepts. If I sketch this parabola on a set of axes, we can see that for a given function we can have a curve like that, and clearly you can see that this curve intersects at y-axis, this curve intersects at x-axis. So these are called the axis intercepts. Okay, we can also find these intercept by simply factorizing the quadratic function and getting the values of x and y. You can easily get the x values here when y is 0, and you can easily get the y value when x is 0. So we will see how we will work them out. And on this curve, you can also see that this is the vertex. In this case, the vertex is the minimum point on the curve. Here we will have the line of symmetry, and you can also work out then the coordinates of this vertex, x and y. There are two methods in finding the coordinates of vertex. We will look into both of these methods in the coming session. From the shape of this curve, because it is a parabola and not an inverted parabola, we can say that for this curve, the coefficient of x square must be greater than 0. That is, x square is positive. All right.